Hi guys, welcome back to my YouTube channel, and in today's video I'm going to be teaching you what icebox calculations are and how you can do them. This is, I think, Unit D of Chemistry 30-1, so let's get started. Okay guys, so first before I start anything, I want to explain to you what an ICE table is. So ICE stands for Initial Change Equilibrium. So in chemistry, we use ICE tables to either find the initial concentration or the change in the concentration, or the concentration after it reaches equilibrium. So there's 3 sections in an icebox, and each section can be used to find something. So that's basically what an icebox is used to for finding stuff. So I'm going to start with the examples. Also, I know you guys want me to put the board on the wall, but I don't really have the materials for that right now. Like, I don't have glue or tape or anything. So you guys are gonna have to wait a bit for that to happen. Sorry. Okay guys, so this is our first example, and the question says, the Kc for reaction A plus B, arrow C plus D is 2.5. Initially, both reactants have a concentration of 4 moles per liters. What is the final concentration of C? So it gave us the initial concentration for A and B, and it's asking us to find the final equilibrium concentration of C. Okay, so first of all, what we're going to do is write down all of the information that we have. So we know that initially both reactants have a concentration of 4 moles per liters. So A and B both have a concentration of 4. I'm going to write that because I can't write with my left hand. Okay guys, so here I wrote the initial concentrations 4 and 4. If the concentration initially on one side has a value, then that automatically means the other side is going to be 0. So for example, if C and D had the concentration of 4, then that would mean A and B would have the initial concentration of 0. Okay? So that's how you start off the ICE table. The next column is the change column. So we don't know what it's changing by, so we have to minus x by 4 because that's how we're going to find the equilibrium concentration. Okay? So the reactants, wherever there's an initial value, is always going to be minus x, and wherever there's 0 as the initial value, it's going to be plus x in the change column. So I'm going to write that out. Okay guys, so here it's the change for the reactants is 4 minus x, and the change for the products is plus x, because 0 plus x is just x. Okay? And keep in mind that wherever the initial is 0, you're adding x, and wherever the initial has a value, you're minusing x. Also, there is a case where it would be 2x or 3x, and that case is when the equation has coefficients. So for example, if C had the coefficient of 3 right here, then we would add 3x. If B had the coefficient of 2 here, we would minus by 2x. Okay, but right now there's no coefficients. All the coefficients are 1, so we don't need to worry about that right now. And now what we want to find is the final concentration for C, and we are given the Kc value. So I made this video assuming you guys know how Kc expression works, but if you don't know, then I'm going to make a separate video about that after this one. But the Kc expression is basically just the ratio of the products over the reactant. Okay, so I'm going to show you guys that. Also, sorry guys, I skipped a step. I automatically wrote 4 minus x here. You don't do that. You just write the change. And the change is minus x and plus x. So you just need to add those in the change column. And then the 4 minus x comes in the equilibrium column, because equilibrium is reached when the initial is minus the change. So you'll get the equilibrium value here. Okay, so that was a small mistake I made. Make sure to pay attention to that. Okay guys, so I just mentioned that the Kc expression is just a ratio of the products over the reactants, and this has to be at equilibrium. So the equilibrium concentration of C times D over the equilibrium concentration of A times B. Okay, and we don't have those values, so we can just substitute what we have over here, the x's. So concentration of C at equilibrium is x because we haven't found it yet. Concentration of D at equilibrium is x. So x times x in the numerator divided by the concentration of the reactants. And the concentration of the reactants we found is 4 minus x and then 4 minus x. Okay, now we just solve this like basic algebraic math. Okay, we're going to multiply the numerators and the denominator, and we're going to solve for x. So the first thing we're going to do, we're given the Kc already, by the way. The Kc, it says, is 2.5. Okay, and whenever you're given something that has no units, you automatically know that it's Kc because Kc has no units. Okay, so we're going to multiply the numerator, which will be x squared, and then we'll multiply the denominator, which is 4 minus x squared. Okay, I'm gonna go ahead and write that out. Okay guys, so I expanded the numerator and the denominator, and they both have squared terms. So what we want to do is we want to get rid of the squares so that it's easier to solve. So what we will do is square root both sides so that we can get rid of the squares. Okay, when we square root both sides, we'll put the value we have here equals to x over 4 minus x. Okay, I'm going to do that. Okay guys, so I went ahead and I did the algebra part. What we did is we square rooted both of these sides, okay? And the square root of 2.5 is 1.58 equals x over 4 minus x. Now we're going to isolate and find what the value of x is. So 1.58, because 4 minus x is being divided here, you'll move it to the other side and it'll get multiplied. And then you'll expand the 1.58 onto each term. So you get 6.32 minus 1.58x equals x. You'll move the x terms to one side and add them, and you'll get 6.32 equals 2.58. Now, because this value is being divided by x, to move it to the other side, we'll divide it by 6.32. So x equals 6.32 over 2.58, which means that x equals 2.45 moles per liters, because we're finding the concentration. X is the concentration at equilibrium. And it's asking us to find the concentration of product C at equilibrium, and that is just X, so we directly have found the concentration of C at equilibrium. If they said to find the concentration of A at equilibrium, we would do 4 minus the X value, which is 2.45, but they're asking for C, so this is going to be our answer. Okay? I think we don't have time for another example because it's already 7 minutes. So I'll make a different video on the other ones. Sorry guys, I try not to keep my videos like longer than 8 or 9 minutes, and it's already like almost 8 minutes now, so I can't really do another example. If you guys want harder examples, then please let me know and I can explain those also. So yeah, thank you guys for watching. If you guys need a video on Kc expressions, which are extremely easy, it'll probably be a 5-minute video, then let me know. Thank you guys for all the suggestions and comments. I really appreciate it. Thank you for watching. Bye.